Hello everyone and welcome to the nation's premier national security research university, the Naval Postgraduate School in Monterey, California. I'm your host for Inside NPS, Alan Richmond. On this show, we'll look at the effects on pollution that the ocean's rip currents have. We'll also talk to one of the pioneers in the internet industry and review some of his major contributions through the years. But first, we thought we'd talk to some of our distinguished professors and ask the question, what does it take to be a good professor or a good teacher?
So that's the first thing we get.
NPS classrooms foster relevant context for applied learning. Praestencia per scientiam, or excellence through knowledge, is demonstrated in classrooms across campus that cultivate applied learning and academic discourse between faculty and an experienced student body comprised of active duty officers representing the U.S. Armed Services and the armed services of many other countries. The student learning experience, outcomes for instruction, and the skillful delivery of discipline-specific knowledge are primary considerations in providing relevant context for applied learning.
All of our students have come in with years of experience, doing some of the things that I'm actually teaching about, and so they bring as much to the table as I do, and that really leads to sort of a wonderful learning environment where you can have them contribute to everybody else's knowledge and understanding as much as I guide them in trying to arrive there.
They're coming back to graduate school to learn some new things so that they can be a decision maker in the future. They bring the operational experience to bear, but we're really not educating them to go back and be an operator. It's more go back and be a decision maker in the future.
These are students that challenge me to be very practical and grounded in what I teach them because they do have such rich experience.
I think what it means to teach well is to convey the material in a way that the students can learn and that's relevant to them in their careers. I think about my previous experiences and what it meant for me to learn well and what I saw other students learning as a graduate student myself. And then I try and set up the course so that all of the things I'm teaching and everything that we're doing in class directly impacts the students' learning for a particular subject.
NPS provides a dynamic context that advances both teaching and learning. Increasingly, the faculty at the Naval Postgraduate School are integrating the concepts and theories of learning and motivation and applying the practices of good teaching to deepen student learning and to develop authentic assessments of student learning.
I think teaching well is about creating conditions for learning well. The challenge is, how do I take what I know sort of innately or intrinsically, make it explicit and accessible to the student? There's sort of two translations that have to occur. I have to take what I know and make it explicit in some form. And then the second part is the student has to pick that up and process it in some way. And so I have to attend to both of those transactions.
The doing of the analytical part and the quantitative aspects of applying methodologies is pretty straightforward because most engineers can handle that. It's that interaction with the end users and with the customers in a way that puts that in the context of making sure that they're solving the right problem with the right sort of solution for them so that they actually have a good context for understanding.
Part of my role in the classroom, having spent time in the region, having been born and raised in that region, is to break down some of these stereotypes and expand the frame of reference for students to show them that the problems that they're dealing with are much more nuanced than they often think.
One of the important parts about this class is taking these tools that are much different than what they're used to and trying to apply it to what they're doing in their curriculum and professional life. It's really about trying to get some experience with the problems, and so what I've tried to do in this class is we'll get together and break out into small group problem-solving sessions, 3 or 4 students per group, and we look at some of these. Oftentimes I try to give them a military scope.
Attention to the student experiences enables faculty to align disciplinary content and pedagogy with formal and informal assessments.
For me, it's not just sort of what they learn, that do they know the facts. In fact, more important to me is how they learn. And that process, the how they learn, is what they take with them and they apply for the rest of their lives.
You have to be instructing and create an intellectually safe and creative space so that they feel free to explore the boundaries of their own knowledge and to try new things and to experiment and be able to fail. The classroom is not only a place where I'm trying to teach them something, but it's also a place where I think that they need to be able to practice exploring intellectually.
To teach well requires that there's a positive emotional tone in the classroom. Positive emotions create what they call the broaden and build effect, that it broadens your ability to make sense of things, it builds and it continues to sort of a virtuous cycle.
When we get to the problem solving and applied learning portion of any type of class, a lot of times there's no right answer. So the interaction with the students is typically, tell me what you're thinking. Let me tell you what I'm thinking. Have you thought of this? Oh, I hadn't thought about that. And it's that critical thinking, problem solving mix where I think the students get the most value.
I sort of want them to look at the problem before they have they are exposed to some of the basic understanding, the basic physics, chemistry of the problem. So they look at the problem, and then as we go along in the course, they start understanding the fundamental mechanisms. And so by the end of the course, they would have an opportunity to analyze the problem in the light of what has been taught in the class.
The NPS faculty continuously seeks to improve the rigor and relevance of critical aspects of the student's learning experience. This process engages students and faculty in reflection about the purposes of learning, the structure of knowledge and its application, and the validity in the processes by which learning is assessed.
To learn well requires that faculty and students are reflective, that they're reflective about their experiences and the models and the concepts that were being presented in the class. That reflection happens in the classroom, it can happen when they're writing, it can happen when they're reading something that another student has written, but it's sort of in multiple places. It's not just in the classroom that learning happens.
I've got one student in particular right now that I'm meeting with every day. As he's learning stuff, I'm learning it at the same time. It's just that as the mentor, I have the opportunity to have a little bit broader perspective, and I can kind of shape him. Having been through the thesis process many, many times, I can kind of let him know where the pitfalls are and when the timeline is getting compressed and those sorts of things.
I allow the students to bring in their own term projects into the course, and it's pretty much open season, and the topics that I get involved in are sometimes Navy related, sometimes not. But working with the students in doing these type of problems, I learn with them, and we have more of a collegial relationship than a student-instructor relationship.
Cultivating the practices of good teaching is a reflective and iterative process, actively engaging both faculty and students in the process of learning.
Oftentimes, if we're talking about a particular subject, they'll say, well, by that logic, what about this story over here in a different subject area? And that's what I'm looking for, is that they're able to sort of apply the same sort of abstract reasoning to a new subject matter and see how it plays out. That to me is a critical indicator that they're sort of getting it, that they're sort of imbibing not only the logic of a particular theoretical approach, but how to apply it.
What I'm really wanting to do is just instill in them a sense of confidence in what they know, and then also what they don't know, and that's okay too. It's good in a sense to develop a healthy respect for intellectual uncertainty and understanding the boundaries of what we actually don't know.
They really get a chance to apply a lot of the things that we talk about. They read about it in the text, but then we actually try to give them hands-on opportunities to collect data on themselves, to observe things. How do we make data about humans and how humans perform, how do we make that in a way that we can measure it and we can make design decisions as a result?
There is some reading that occurs that provides some new information. There needs to be some discourse and dialogue in the classroom, the conference part, which makes that student ready or able to use some of that new information. And then writing assignments, homework, exams, papers, and things, because the process of writing it down and choosing specific words and phrasing things carefully refines and makes that thinking more precise.
The DL is a tricky piece. When you do learning objectives or outcomes, you really have to sit down and plan it all out like a campaign. You could have the greatest class ever, but without the student interaction, you're just not going to be successful.
A lot of our students have spent time in the regions that I teach about, or have been in areas or dealt with problems that really bring these issues to life. That is really what I look for, students that not only learn from me, but I feel that I learned something from them.
When students come to the office with a problem which they don't quite understand, the primary thing is that they have thought about it for some time. And so I never tell them the answer. I always guide them through the answer. That reinforces their understanding. Many times they come up with problems which I have not seen, and so they come up with some of these, and then I can think about, oh, okay, this is how it works in a real situation.
Achieving the educational mission of the Naval Postgraduate School challenges students and faculty to learn with and from one another what it means to teach and to learn something well.
Often, just in the question that comes out, you can realize that the student has at least thought about it. Whether he's thought about it correctly or not is not always easy to pinpoint on the spot.
I try to listen to the question behind the question, because oftentimes, particularly with new material, the student isn't quite sure how to phrase the question, and so I try to understand the motivation behind the question.
It can be fun as well to try to figure out how to get people with more experience to actually, in ways, mentor and help get the learning objectives across to the people who don't have as much experience. Being able to have this dialogue among everyone, and sometimes it turns into a facilitated dialogue. The reality that can be reflected back by the people who have a lot of experience out there can be invaluable, because they can start to add aspects of how this thing really might have worked in a particular situation they had.
That kind of situational-based question is a good indicator that the students are like, oh, okay, I remember what we talked about in class. Now, if I were in this situation, this is how I would go about doing things. And with our DL folks, that's very tangible. That can have a lot of practical benefits, because they walk out of that door and they are working for a chief engineer, or working as a chief engineer, or working in some technical field on a new development or on a fielded system that's been around for a while. And so to have that in the test and go, oh yeah, okay, and to have that in the classroom, and for them to be able to go outside the classroom and make use of it, I mean, that's really the best thing.
Faculty incorporate multiple measures to assess teaching and learning.
I think grades are really only a slight reflection of what they've learned, because I think a reflection of what they've learned here really comes from within them. If I get a student to be a thesis student, and that growth process continues as they take on different projects and design and engineering projects, I often get students coming back a quarter or 2, 3 quarters later, and they'll say, Professor Adams, your class was great, it's applicable, I was able to use it here, here, and here, and it's that intertwining of all the education they get here that's really important.
So many of our students here are self-motivated, and they get out front on the problems and try to solve them. And so it's a lot of fun to watch them. What I always remember most, of course, are the students who really didn't need me, the ones who kind of went off on their own, and you just kind of throw them stuff and they just eat it alive. Just give him what he needs and get out of his way.
What I look for is, are you able to really show me that you have learned something about the region, that you are able to incorporate the theories that we have discussed to analyze problems in the region, and are your answers authoritative?
Getting them to value that kind of intellectual uncertainty at the end, I think is a big challenge, and for them to understand that at the end of the day, when I have more questions, I actually have more knowledge because I know what questions to ask now.
NPS classrooms foster meaningful context for applied and relevant learning while contributing to the operational readiness of the U.S. Armed Forces, our global partners, the Department of Defense, and the Department of the Navy. Stay tuned for more on Inside NPS right after this. Recently, we had the pleasure of hosting Dr. Irwin Jacobs as our graduation speaker. Now, Dr. Jacobs is the founder of Qualcomm and a pioneer in the internet industry. We had a chance to ask him a few questions about the unique contributions he's personally made to the industry through the years. Dr. Jacobs, thank you so much for taking time to be with us on Inside NPS and for being the graduation speaker here at the Naval Postgraduate School. Now, you've had such an illustrious career, and one of those things is a book that you published in the mid-1960s that you co-authored with Jack Wozencraft that's still in use today, isn't it?
Right. We published in '65. We began, the we being Jack Wozencraft, who actually was a professor here at the Navy Postgraduate School after he left MIT. And myself, we were both young faculty at the time, both interested in communications and information theory. And so we were asked if we would teach a course to the senior class on information theory. Until then, it had been only a graduate program. And so we decided we'd do that, and then between us agreed that rather than teaching it as applied mathematics, that perhaps sometime there would be some applications for this, so we should teach it in a way that leads toward the engineering applications. And we did that, put together class notes, refined those, and eventually we then published a book, which did come out in 1965. The amazing thing to me, because technology changes so quickly, is the book is still being used in a number of classes. And so although I travel around to many different countries these days, it always feels a little bit like home because somebody always comes up to me and says, you know, I studied from that book.
Well, you're also the founder of a very, very important and well-known company called Qualcomm. How did that come into existence?
Right. Well, we sold Linkabit in 1980. I stayed on until 1985. We did a number of very interesting commercial programs in that time. The first television to home TV, scrambling capability, first very small aperture Earth terminals, the first commercial TDMA phone. But I decided to leave in '85 and retired. And that retirement lasted 3 months. I often say flunked retirement. And several of the people that had been with me at Linkabit kept coming and saying, let's do it again. So we decided we'd start a company, and this was July of 1985. Start a company, we'll call it Quality Communications, Qualcomm, because of the emphasis on quality. And that we didn't have any particular product, we didn't have any particular business in mind, other than we knew digital will always be popular and wireless would probably be very popular. So we looked for projects there.
Well, you've made so many unique contributions through the years, and we thank you for that. Did you ever realize along the way how huge those contributions would be?
When you do these, you see some of the technical advantages, and you think that, yes, there will be a market for them. Other people might recognize, and then you begin to, make a few predictions of what's the business case for doing this. And then you get a number, and then you scale it down by a factor 2, and that still doesn't make sense. Scale it down another factor 2. Well, this is a case where, yes, it's just exceeded all of our expectations.
Well, you've had quite a distinguished career, and we thank you for all your unique contributions. It must be quite rewarding to you personally as you look back on those.
Well, it's always exciting, and the wonderful thing is there's always yet another decade of very good things to be done. And so in this case of the cell phones, one can attach various sensors to the cell phones. So for example, you can have some that do environmental monitoring. You've got so many of these cell phones around, you can bring back the information periodically, process it, and for example, if there's going to be an epidemic, begin to perhaps to get an advanced indication thereof. There are other sensors that you can use that perhaps can watch blood flow, can watch signals for diabetes, a whole range of different possibilities. A lot of these types of sensors generate a lot of noise in a sense. There's a lot of false signals as well as the information you want to gather. But by sending it to the cell phone, which has this large computer, you can go ahead and filter it, decide which is important, which is not important, and then let the user know if it's important, send it to the family, send it to a doctor. And so one has that great advantage.
Well, thank you very much for being with us today at the Naval Postgraduate School. We hope to see you again soon. We'll be back with more of Inside NPS right after this message. Recently, we had the opportunity to visit with our Department of Oceanography at one of their experiment sites on Monterey Bay. We look at the issue of pollution and one of their experiments to tell us more.
Today we're getting ready for a dye/drifter deployment, and what we're looking at is the cross-shore exchange of material from the surf zone beyond the wave breaking, which is referred to as the inner shelf.
Which buoy was that? The third one he deployed or the fourth one? So we have floating drifters out there with also these small GPSs on them, and they have a line coming down underwater, and there's a dye sensor, a fluorometer, that's about 2 feet from the surface of the water, and it's also weighted, and they're putting 5 of them out there and offshore of the shoals and the rip channels.
You can see these guys down here with the big tubs of dye. They're going to go out here onto this shoal where the waves are breaking, and they're going to release that dye, and the whole surf zone's going to turn pink. And what that does is it dyes the water, and so that we can follow those patches of water as they move around, and we get to see waves breaking, they push the water, and the water goes out in rip currents. We're going to drop a bunch of these drifters in the water. And these are flow-following drifters. They'll just march along like little soldiers, and wherever the water goes, they go. So they sit at the surface mostly, and some of our fluorometer measurements are down near the bed, so it's also the difference between what happens at the surface and what happens deeper down. And the drifters just follow the currents out there. And so again, what we like to see is the drifters, they go offshore with the rip currents, and then they move back in with the waves, and they go offshore with the rip currents. Or they might go down the beach and in a longshore current. We can never be quite sure. These are the things we're trying to measure and understand. Some of the instruments that we put in the water that I just referred to are fluorometers, which actually measure that pink dye, specifically that wavelength of light. And so we have fixed fluorometers that are going to measure if the dye comes past them. And then the boats out there have fluorometers on them, and they're going to drive back and forth as that dye makes its way out of the surf zone via the rip currents. And one of the things they're interested in is how much exchange between the surf and the offshore happens. So they're very interested to know how much of that dye makes it offshore to the boats.
We deployed it on the shoal, which is the shallow part where the waves are breaking. And the breaking waves bring it in, and then it converges here in the rip current. And then it goes out through the rip current outside, flowing to the south. So you see this sort of meandering of the dye. So it gives you a really good idea about the flow circulations and transport patterns, because that's what we're looking at. The idea is that it stays within a certain boundary. So we have instruments at the lateral boundary, so we can measure how much dye and flow is going out.
And this allows us to understand how pollutants or larvae and biological biota, we are trying to understand how it moves and the flushing rate of the surf zone so that we can describe water quality, which is important for beachgoers. Especially with the recent oil spill, we want to understand how things are going to move in and out.
Hello, I'm Dan Oliver, President of the Naval Postgraduate School in Monterey, California. NPS is blessed with a world-class faculty that provide unique, relevant, advanced education and research programs that increase the combat effectiveness of our naval services, our sister services, those of our partners and allies, in order to enhance our national security. NPS has a long and celebrated history. During this, our centennial year, I invite you personally to come out and visit so that you can see firsthand what a world-class institution NPS really is. Thank you.
What I learned here at NPS and specifically in my curriculum is going to help me in any job that I go to, because I think it's just gotten me back into that academic mode, learning more, keeping up with current events, and just giving a better perspective of what's going on across DoD and across the international community.
One of the best things about Naval Postgraduate School is they bring together not only experts in the academic field, but also from the military profession, and it kind of melds those two and provides a unique perspective that I think other institutions that are great just aren't able to provide to the military professionals specifically.
Once you come here to NPS, it drastically changes the way you think about operations and strategy, and being able to walk out of here with that kind of thought process will really help me be able to articulate to my future bosses, and eventually, if I am a commander, to be able to articulate what I need as a commander to get things done. And this is just a way to provide that foundation for you.
Getting the chance to live in Monterey or in the Monterey Bay area, to experience coming to school here, getting this level of education, working with the faculty, they're top-notch, and the education that you're going to get coming out of here is right along with any graduate program that the military has to offer. And so I would encourage any person that gets an opportunity to come to NPS to take advantage of it, because it's a once-in-a-lifetime opportunity and they're not going to regret it.
Well, that's it for this edition of Inside the Naval Postgraduate School from Monterey, California. I'm Alan Richmond. We'll see you next time.